When you look up at the night sky, you're staring into infinity, a universe filled with billions of stars, galaxies, and blazing suns. And yet, it's black. Endless black. It's one of the strangest paradoxes in the cosmos. If the universe is full of light, why does it look so dark? Why doesn't the night sky glow as bright as day? This question might sound simple, but it puzzled astronomers for centuries, and the answer reveals something profound about the universe itself. To understand the darkness of space, let's start with something familiar: daylight. When you stand under the sun on Earth, the sky is bright blue. That's because sunlight hits the atmosphere, the gases, dust, and particles, and gets scattered. Blue light, which has shorter wavelengths, scatters more than red light. So we see a glowing blue dome above us. In space, there's no atmosphere, no air, no scattering. So when light travels through that emptiness, it doesn't bounce or spread, it just keeps going in a straight line, invisible, unless it hits something. That's why astronauts who stand above Earth see darkness everywhere, except when they look down, where sunlight reflects off the planet's surface. It's not that space has no light, it's that there's nothing there for light to bounce off. But this explanation, while true, is just the beginning. Because even if light doesn't scatter, there's still another question. If stars are shining in all directions, billions of them, shouldn't their light overlap, blending together to fill the sky with brightness? Why don't all those stars make the universe glow like one giant sun? That mystery is known as Olbers Paradox, named after the German astronomer Heinrich Olbers, who asked it in the early 1800s. He reasoned if the universe were infinite, eternal, and filled evenly with stars, then no matter where you looked, your line of sight would eventually hit a star. In that case, the night sky should be as bright as the surface of the sun. But it's not. It's black. So something in that logic must be wrong. The truth is, the universe isn't infinite in age. It had a beginning, the Big Bang, about 13.8 billion years ago. That means light has only had 13.8 billion years to travel. Stars that are farther away than that, their light simply hasn't reached us yet. So there are cosmic regions we can't see, not because they're dark, but because their light is still on its way. In other words, the darkness of the universe isn't the absence of stars. It's the limit of time. Even more fascinating, not all stars have existed forever. Most formed billions of years after the Big Bang. So if you were somehow floating in the early universe right after its birth, the sky wouldn't be black. It would be glowing with radiation, a brilliant cosmic fog of energy. But as the universe expanded, that light stretched. Its wavelength grew longer and longer until it shifted out of the visible spectrum. What was once bright, white-hot light became invisible cosmic microwave background radiation, a faint echo of the Big Bang that scientists can still detect today. That expansion is still happening right now, and as space stretches, light from distant galaxies keeps getting redshifted, fading beyond the range of our eyes. That's why the universe looks dark, even though it's still full of light. So, when you stare into the night sky, you're not looking into emptiness. You're looking into time itself. Each star you see is a window into the past. Some of that light left its star before the Earth even existed. Other stars, long dead, still shine in your eyes because their light is only arriving now. You are quite literally seeing the ghosts of suns that burned out millions or billions of years ago. But still, that black background, that endless void, remains. Because most of the universe isn't filled with stars. It's filled with space. Cold, expanding, silent space. And that space is growing faster than light can cross it. Entire galaxies are drifting away so quickly that their light will never reach us. They are disappearing over the cosmic horizon, forever invisible. In time, billions of years from now, even the galaxies we can see today will fade into darkness. The universe will become emptier, quieter, darker. That's not just poetic, it's physics. The energy that once filled the universe with brilliance is being diluted as space itself expands. Light stretches into infrared, then microwave, and eventually radio waves, until there's no visible light left. The future of the universe isn't fiery chaos, it's silence. And yet, in that silence, there's beauty. The blackness of space is not a void, it's the canvas upon which all creation is painted. Without darkness, stars wouldn't shine. Their light means nothing without the night to hold it. Every photon that reaches your eye has traveled across unimaginable distances just to meet you. So, when you look up at the night sky and feel small, remember, you're witnessing a universe still expanding, still glowing beyond what your eyes can see. The darkness isn't empty. It's full of light too far, too old, and too stretched for us to perceive. The next time you step outside on a clear night, take a moment. Look up. That black sky isn't a wall. It's a story. 13.8 billion years in the making. Every flicker, every shadow, every dark patch you see is a clue to where we came from and where everything is headed. Because in the end, space isn't dark. We just can't see its light anymore. If you love exploring mysteries like this, don't forget to like, share, and subscribe to WiseUse, where science meets wonder, and every question opens another galaxy of answers.